Hey everyone, Jay here again. Another Intro to Python lab. This is lab 11 in my fall 2022 series. We're doing loops again. This time we're going to put some loops inside of each other, four in total. So an outer loop, and then a loop inside of that, a loop inside of that, and a loop inside of that. What we're going to do is we're going to emulate a 4-digit binary counter. Okay, this is not very advanced. It's going to count 0 1 0 1 0 1 0 1 with each loop is going to be one of the digits in there, and you'll see how we do that. But this really is just a very simple way of showing you how loops inside of loops work. Okay, oftentimes we put loops inside of loops. We're going to make it go 100, maybe 1,000 times over. We're just going to have it go over 2 times each. Okay, and we'll see what that looks like. So I have my loops already made. I have an overall value that I'm calling counter. So every time the loop runs, the innermost loop, every time that one runs, my counter is going to tick 1 time. And we have 4 loops, one for each of the binary digits. We're just going to do the first 4. So starting from 0, 0, 0, 0, that should go up to 15, okay, for 16 total values. So that's the counter, and you'll see in my print statement, I'm going to print the counter at the end. You know what? I should just show you what it looks like in the end to give you an idea of what we're going to do. Okay, so I'm going to run this, and this is what it prints. Okay, each loop controls 1 digit. So the outermost loop controls the first digit, and then the next loop controls the second digit. The next loop controls the third digit, and the innermost loop controls the fourth digit. The innermost loop, it's going to execute its full cycle, and then its parent loop is going to execute once, and then the inner one's going to do its full cycle again, and then its parent is going to execute once, and then the inner loop is going to do its cycle again. So just like these digits, the inner loop is just going and going and going every time, 0 1 0 1 0 1 0 1 0 1, and each loop is executing less times. Okay, less times overall, right? So the outer loop, that very first loop, it starts at 0, and then it doesn't do anything, and then it changes to 1, and then it doesn't do anything, and then it exits. That's it. And then the innermost loop is going to do, or the second inner loop is going to go start at 0. Everything inside that is going to run. Then it's going to tick to 1 right here. And then everything inside that's going to run. And then it's going to tick back to 0 again. And it's going to tick the outer loop over to 1. So let's have a look at this. Let's go back inside and see the code. Okay. So my first loop, my control value is called I for an iterator. Okay. That's a very common loop control value, is just the variable I. You'll create it, set it equal to whatever you want. In my case, it's set to 0. And then I've said while I is less than or equal to 1, do all this stuff in here. Okay, everything here is inside the loop. It's everything here. This is all inside the loop. It's all tabbed over 1 time. Okay, so in that loop, I'm going to run all the body of the other code, and at the end, I'm going to increment I plus equal to 1. That's right down here. And then after it does that, it goes back up here, and as long as it's less than or equal to 1, and it will be once, right, when it's equal to 1, and then it'll do all this again, and then it will stop, because then it will be equal to 2. And you'll notice there are no 2's down here in the output, except for the counter, of course. There are no 2's in the binary digits, so as soon as this value is no longer less than or equal to 1, the while loop says, nope, that's not true anymore. It doesn't do any of this. It skips it, and then it proceeds with the remainder of the program. In my case, there's nothing else, so it stops the program. Okay, so the first loop starts at 0, runs all this, increments I by 1, I is less than or equal to 1. It runs all this again, increments I by 1. I is now 2, so it skips all this and this, skips that too, okay, because that's inside the loop. So it skips all this once I becomes 2, and then goes down to, in my case, it goes down to line 32. There's nothing there. That's the end of the program. Then we stop. Okay, so let's look inside of the first loop. It's going to set J, okay, I, J, K, L. Those are the incrementers I'm using. J is equal to 0. While J is less than or equal to 1, run all of this. Okay, and what it's going to do is some more loops. At the end, it's going to increment J. It's going to do the exact same thing as the first loop. And that we're just one step in, and so it's going to do less loops every time, right? So J is going to run, I is going to be 0, it's going to run, increment J, sorry. I of J is going to be 1, it's going to run this, then J is going to be 2, then it's going to test, it's not less than or equal to 1, it's going to skip all this, go down to here, pass control back up to the outer loop, and we've already established what that's going to do, right? Then the K loop is going to do the same thing again. It's going to execute all of this. K is equal to 0. Run all that. Increment K. K is equal to 1. That's less than or equal to 1. So we're going to run all this again. Come back up. After we increment, K will be 2. So then it does not run all this. And then passes control back up to the J loop, which does its thing. It passes control back up to the I loop, which does its thing. And now we're at the innermost loop, the L loop. Okay, L starts at 0, while L is less than or equal to 1, starts at 0, so it will be. Now we're going to do something. Now we're going to print placeholder, 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 oops, 4 placeholders, one for I, J, K, and L, equals another placeholder that I'm going to format to be 2 decimal places. And I want to format it 2 decimal places so that on my output, if you'll see down here, my output aligns up to the right. So if I had like money in there, all the decimal points would line up. I like to do it that way. So that's my text that I'm going to print, and I'm going to use the format command for the format function, and I'm going to put I in the first placeholder, J in the second placeholder, K in the third placeholder, L in the fourth placeholder, followed by counter in the last placeholder. Okay, I'm going to print all that. Then after I print it, that's when I'm going to increment L. If I increment L first, then I will never print the time that L equaled 0. And then instead of printing when L equals 1, I will print when L equals, instead of 0 and 1, it'll print 1 and 2. And we don't want to do that. We want to print before the increment takes place. So then at the very end, or at the very end each time, each loop cycle, when L adds up to 2 and it fails this while, it doesn't print that time when it's 2. So I only want it to print when L is 0 and when L is 1, right? And also every time L increments, because that's the innermost thing, I want to increment the overall counter. Now what I don't want to do is increment the counter every single time when all of these are incremented, because every time L increments, it's going to do the L cycle, and then it's going to bump up when it finishes that whole cycle. It's going to bump up, and K is going to increment. So every time K increments, L has also incremented. Every time J increments, K and L has also incremented. And every time I increments, J, K, and L have also incremented. If I put counter plus equals 1 on all of them, right? Let's look at our code, our output of our code. Okay, it is incrementing only when the innermost loop runs, and it counts 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way through 15, like it's supposed to. If I were to copy and paste this counter, and I were to accidentally increment it every time along with all of them, and then I ran it, what I'm going to get is 0, 1, 3, 4, 7, 8, 10, 11, 15, 16. Notice I'm getting pairs because every time L runs is the inner one and it runs all of them. And then K is going to skip it and then it's going to run all of them. And then K and J is going to skip ahead and then it's going to run this again. And then K, J, and I are all going to increment counter. So instead of counting from 0 to 15 like it should, I ended up counting from 0, skipping a lot of the numbers and ending up at 26. So when you're constructing your loops and you're counting things, make sure that you increment at the proper locations. Okay. And I'll run that again, and you'll see that it is counting just fine. All right, something to keep an eye on while we're running Python is all of our tabs. Every time you go in a loop or in an if statement or in a function, which we haven't got to yet, but we will, every time you go into one of these, you need to tab over one time. And when you go into the next one, you need to tab over one time. So if you're looking at the tabs, it does line up and it takes a little getting used to. Right? In other programming language, we would have curly braces at the top and bottom of each of these while loops. And that is pretty handy for identifying the end of the loop. And in those languages with curly braces, the tabbing over isn't very strict at all. So those get a little bit hard to read as well. So it's at some point, these loops get a little crazy because when we're down here, at the very last one, like you might think, oh, which loop am I in? Well, just slide up your eye to see where it lines up, and it's one tab into the outer loop. That's what this one is. So we know that this is part of the outer loop. Okay. Some IDEs will have really thin lines drawn down so that you can see and it's easier to line up, because oftentimes if your code is really, really, really long, it will get, you won't even be able to fit the top and bottom of a loop structure on the screen at one time. And then it becomes very hard. But some IDEs will have a little line drawn there, and they may also have a little collapse and expand option that you can do. That's really just, it doesn't affect the code. It just affects how you look at it while you're editing it. So those are nice if you need that. And if you get used to using that, right? Those are pretty nice. But this is nested loops inside of each other. It is a loop within a loop within a loop within a loop, right? So quite a lot of inception going on here. But this is all the code you need for this lab. A lot of zeros and ones because we're printing binary in the end. And then we'll have a look at the output one more time. There you go. And again, thanks for watching, and I'll see you next time.